Well, it's 2 minutes after. I could say a quick good morning from ESIP. Hopefully you are all in the room for the best practices and reusability of machine learning models. Looks like we still have some people streaming in. A reminder to see the Google Doc that's linked for this session in Kiko chat. Oh, everyone's really on top of it this morning. Thank you. If you can go ahead and add your name and affiliation to the attendance and check-in. And looks like everyone is going for that. And then I will pass it over. Hamed, are you going to kick things off?
Yeah, I can do that with Sanjay.
Okay.
Awesome. Thank you, Annie. Hello, everyone. Good morning, good afternoon, or good evening to you, depending on where you're around the world. And welcome to the session on best practices for reusability of machine learning models. We're going to talk about some guidelines and best practices, as well as a specification about geospatial models. I'm running this session joined with my colleague Sanjay. I will let Sanjay also introduce himself, then I will continue. Sanjay, do you want to say a word?
Hi, good morning, everyone. Good morning, good afternoon, good evening. I'm Sanjay Purushottam. I'm an assistant professor in the Department of Information Systems at UMBC. Looking forward to having a great conversation with you today.
Awesome. Thank you, Sanjay. And yeah, I forgot to say my affiliation. I'm Hamed Al Mohammed. I'm Chief Data Scientist and Executive Director with Radiant Earth Foundation. We also have two other speakers that we'll introduce them later in the session. But as Annie mentioned, please put your name and affiliations in the Google Doc. Down in the sheet on the third page, there's also a section for note-taking. That's Sanjay and I are kind of leading that with the help from our ESIP colleagues, but please jump in and put any comments or notes from the session in there. This is really a collaborative note-taking practice. We will have about half an hour of presentations and Q&A. We have 3 presentations aligned with like 8-minute presentation, 2-minute Q&A after each of those. And then we will have about 35 minutes of breakout sessions that we will go over the logistics and some questions that are going to be targeted in those. You don't need to choose your breakout room. Discussions will be similar. So we are going to randomly assign people, and each room will have a moderator. So and then after that, we will have about 15 to 20 minutes of report out from each of those groups based on the questions you have discussed, and about 5 minutes at the end for wrap up and conclusions from there. If you have any questions in between, feel free to put it in the chat. We'll attend to those. But during the Q&A, we will also, sorry for the background fire truck. We will also you can raise your hand and ask questions after each presentation. So a quick 1 minute about why we are running this session. I mean, machine learning is a very much data-driven pipeline, as we all know, and it is kind of, I would say, revolutionizing how we are doing earth science these days. But a key piece of that puzzle is how we can do fair ML, fair, the principles that ESIP has been the steward of that, definable, accessible, interoperable, and reusable kind of principles. They have been applied to data for a couple of years now. They introduced back, I think, in 2015 or 2016. But now more and more, we need to think about the other pieces of the machine learning pipeline, particularly the ML models themselves. So we are going to start with a presentation from the FAIR ML group about what are the considerations when you're thinking about FAIR ML, and then specifically jump into the reusability issues. When there is a model out there, someone, a researcher, a practitioner has published a model, how you can reuse that, what are the constraints there, what are the things we should do differently, or what are the basically kind of best practices and guidelines to think about that. And then jump into a kind of discussion about what should we tell our community down the road to better publish their models and be able to reuse and reproduce the results of that. And we're going to distinguish between reuse and reproduce in one of the slides later on. Without further ado, I will basically jump into the presentations. Sanjay, do you have anything else you want to add before I introduce our first speaker?
I think we are good to go. Yeah.
Okay, so with that, our first presenter is Fotis Somopoulos. I think I did that right, from the Center for Research and Technology, Hellas. Fotis, floor is yours.
Thanks, Hamed. You should be able to see my screen now, sorry.
Yes.
Perfect. All right. So thanks for the invite. First of all, I'm very happy to talk about the FAIR for ML here. This is sort of an effort that I'm running together with Dan Katz from the University of Illinois. He would be here, but unfortunately, other circumstances sort of pushed this to me. So this is a fairly recent effort. It will be doing this on and off for the past year, I'd say. But we are really pushing this forward, and I'd like to share this with you today. So as Hamid said, these are sort of the FAIR principles. I'm hoping that they are at least a bit familiar with everyone here. They were essentially start the discussion about the FAIR principles about 2013, but the first sort of article that was out there was in 2016, where the FAIR principles for data were essentially published. The four main pillars, findable, accessible, discoverable, reusable, were constantly analyzed further into principles, guidelines, and so forth, which were consequently used in a different context. That being said, the FAIR principles for themselves were eventually implemented mostly for data. Although at a higher level, the principles themselves can be applied to pretty much any kind of research object. And these include both the objects that are used for research, as well as the outcomes of research itself. If you look at the principles, they look a lot around data and metadata. So this means that basically by definition, from the get-go, these principles were effectively designed to be applied for data sets, be that repositories, documents, any kind of a data-related object, which leads to the question of, all right, we have the FAIR principles for data objects, but what about not data objects? At a higher level, the principles stay the same. We want these objects to be findable, accessible, interoperable, and reusable. However, looking at the details and how this can be sort of applied in a practical context is what actually identifies these differences between data and non-data data types. So essentially, if you try to go in the road of FAIR for non-data objects, essentially you need to define those principles in this context, and then essentially how to implement through providing guidelines. So what we focus here essentially is how to adapt and how to ensure practical guidelines for the adoption of the FAIR principles for machine learning. And this is something that is also connected to a lot of efforts around the world. And the European Open Science Cloud, the task force has actually put out recently the recommendation for implementation of FAIR practice that hints to other digital objects beyond data. And this is sort of a critical aspect here. It may be worth highlighting here that there's already been some work for for not data objects and software in this context. This is an effort in RDA, a joint RDA, Force 11 and RISA task force, which essentially attempts to define how these FAIR principles can be applied for software. This is already been in progress. These days, actually, the final outcome of this effort is being under community consideration. But the key highlight that I want to bring here is that this was really a community discussion that really brought forth the key differences that apply between software and code, essentially, and data under the FAIR context. So looking at yet a bit broadly, the original FAIR principles claim or are aimed to be applied to any kind of a digital object. In practice, they tend to focus on metadata and data. There's been a lot of work for software. This is a bit of a mature state at this point, as well as workflows. And for workflows itself, the main concept was how to define for the workflow as a process in total. Looking at machine learning, this is still an open question, because the question essentially boils down to how we interpret the model itself. It could be data, in the sense that a model itself is produced by a set of parameters, and the definition of the algorithm, of the method, the options, how all this is put together. On the other hand, you can say that it's kind of a software. It's the output of this process that can be used as is, that takes something as input and provide a distinct output, your prediction, your grouping, whatever. But it can also be something completely different, something that goes beyond those 2 points. So essentially, this is the stage that we are right now. We are trying to figure out what would be the appropriate way of dealing with machine learning if we look it under the context of fairness. You could look this as an application to repositories. So right now we have a large element of the FAIR principles to be applied for data and metadata that could be extended to machine learning. But this is not necessarily the best solution. Even software, which is typically shared through sort of social platforms like GitHub, this is not, by definition, a fairness platform. Essentially, the same could be said for package management. If you look at the machine learning models and making this same connection, how you can access them, you can find machine learning models repositories. There do exist efforts that deposit machine learning models in there and could potentially be findable. But at the same time, you can say that you can provide a platform, you execute those models, and then this would be your repository. And finally, you can have efforts like DL Hub and OpenML, which take into consideration the entire pipeline, the process of machine learning, where model and data are grouped together, are provided together with a code, potentially that is the background in this case. Which again brings back the same question: should data, models, process, code, all of those be bundled together? Should they be distinct? What should be the appropriate case? So this is a discussion that we've been having essentially a bit over than a year now. It first started as a poster that we submitted in November 2020 under RDA, the Virtual Plenary 16. This led to a dedicated BOF session in April last year, where we essentially had an overview of what is the current situation, and we invited particular projects, efforts, and initiatives to provide the context. Overall, this generated a lot of interest, which led to a sort of first community call, if you like, that took place literally yesterday, almost same time as today, where we had a few people sort of exchange ideas and how to move forward. We also plan to submit another beta further in the upcoming virtual plenary of RDA in 2018, essentially thinking if we can kick off this as a more structured organization under RDA. In closing, and this is sort of my last slide, there are a lot of relevant projects for fairness in machine learning. They may not directly apply FAIR, but they are relevant to this discussion. This can go from platforms to communities that are like the Pisoia Land, which is really life science and industry oriented, or Elixir, which is really academic and life science oriented. The CLARE network in Europe, which is basically a federation of AI labs, and also projects like the one that Dan is actively involved in, that actually looks at FAIR for AI in higher particle physics. In short, and I'll close with that, we are really kickstarting the discussion here. We're looking at the more immediate steps from September onwards. So if anyone is actually interested in helping out and participating to this discussion, please feel free to reach out to me or Dan. And with that, I hope I did not take over time. And thank you.
Thank you for this. So we have about 1 minute for questions. You can raise your hand or type it in the chat. And I also encourage for the next presentations, start typing your questions beforehand in the chat. That might be helpful. But feel free to raise your hand if you want to ask a question now. If not, I might ask a question myself. So, well, one question I had back to your basic discussions about the working group. Is there any way for interested people to join that working group? What is the mechanism for that?
So right now it's basically an ad hoc group. So there is no particular mechanism in place because we are basically a community of people who are interested in the topic. If eventually this ends up to being an RDA group, for example, or whatever other organization, the structure will be defined by that. I'm fairly familiar with RDA, which is really an open organization, so everyone can participate. But for the time being, and until we decide on what would be a potential structure if it goes to that, the easiest solution would be to reach out to me or Dan and to keep you basically in the loop.
Awesome. Thank you for this. I don't see any raised hand or any other questions. Okay, hopefully we'll have more discussions in the breakout sessions. So the next presentation is actually by Sanjay and I. We are gonna provide a report out from our NASA working group about model reusability. I will pass it to Sanjay to start.
Thanks, Ahmed. Can you see my screen?
Yes.
Okay. Thanks. Good morning, good afternoon, good evening, everyone. Today, I will be presenting the activities we are undertaking as part of NASA Machine Learning Model Capacity Reusability Working Group, which is part of Earth Science Data Systems Working Group. As I mentioned before, my name is Sanjay. I'm co-leading this working group along with my colleague Ahmed, who is co-organizing this session. In this presentation, we'll talk about what we mean by reusability and how we are tackling this challenge, and what are the best practices of reusability for machine learning we are thinking about and discussing in this working group. So this is a brief outline. First, I'll introduce the topic of model reusability, which Fortis touched in as first talk to some extent. Then I'll do a brief literature review on this topic from AI and machine learning perspective. Mainly, I'll summarize the research works from the community. This will give you some ideas about how you can think about model usability for your own work. And then I will then Hamid will take over and talk about the challenges of achieving model reusability. And this will segue to the activities we are actually conducting in our NASA working group, which Ahmed will present. So next slide. So what do we mean by model reuse or model reusability? So model reuse actually attempts to construct a new model, by utilizing existing available models, which the existing available models are trained on different other tasks, rather than the tasks of interest. And the goal here is we don't want to build a model from scratch, but reuse existing models. That's the main goal of model reuse. So the goal of model reuse is to reduce the need for learning resources for a new target task. And this actually helps to reduce the time cost, data amount, and the expertise required. So in model reuse, the model may be trained under very different tasks compared to the one which is of interest. But the assumption here is all the information on those tasks can be only observed to the models and their specifications, which John will talk about a little bit about model specifications in the next presentation. In our perspective, we consider model reuse in all these scenarios, using pre-trained models, transfer learning, federated learning, and through the use of model specifications. So using pre-trained models is something I'll talk about in the next slide. Most of the work in AI and machine learning focus on how to reuse the existing models. A brief note on transfer learning and federated learning. Transfer learning is actually a problem in machine learning that focuses on learning knowledge and storing knowledge from one task and applying or using that knowledge to solve some other task, which is different but related to the original task. So you're trying to somewhat transfer the knowledge from one task or one data set to the other data set, or from using it through a model. Okay, that's the main idea for transfer learning. Federated learning is also known as collaborative learning, and it's a machine learning technique which trains an algorithm across multiple decentralized devices or servers which are holding local data copies. Without actually exchanging them, you basically train local models on individual servers in a decentralized fashion and aggregate their information in using some particular algorithm. So this idea is known as federated learning, and this has actually been used recently by many internet companies for learning preferences from different audience or different people. For example, Google uses federated learning to learn your typing habits on, say, on your mobile phone. This is federated learning, and model specification, John will touch upon it in the next slide. So compared to the transfer learning and federated learning, right, the original problem of reusing the pre-trained models is slightly different, because here you're assuming that the pre-trained models are given and you don't have access to the original training data sets. So you want to use the pre-trained models to actually use it for your own prediction task. So that's the brief introduction to like what model reuse is. And now I'll mainly do a brief literature review about the first task, that is how to use the pre-trained models. This has been some work, there has been some work recently in the AI and machine learning community on how to reuse pre-trained models. And these are some of the works which have been published very recently in the past 3 to 4 years in the top AI and machine learning conferences like AAAI, ICHKI, etc. Most of them talk about the algorithmic part, how to use it, not specific to any particular application. But I just wanted to share these some ideas from these papers to get your get the idea across to you, so that you can start thinking about them for your own research problems. So the first work is called as fixed model reuse, and at the bottom is the figure. So what it is actually doing. So the fixed model reuse utilizes the learning power of deep learning models to implicitly grab the useful discriminative information from a fixed model or some fixed features that have been widely used in general tasks, some other tasks. So the FMR, fixed model reuse, arranges the deep learning and the sophisticated models of features in parallel initially, and uses a technique called as knockdown, which gradually eliminates the influence of the fixed model or the pre-trained model, and so that eventually the deep learner relies only on the raw input features to predict for the target task. So that's the main idea behind the fixed model reuse. The second work talks about how do you combine multiple pre-trained models for many applications, right? Instead of using one pre-trained model, you want to use multiple pre-trained models to achieve better consistency. So this talks about how do you learn different models for different modalities and combine them so that you get the best result possible. The third technique talks about boosting, where you can use the boosting algorithm to combine different models. Instead of choosing all the pre-trained models, you choose a subset of pre-trained models, and how you can do it by using a boosting algorithm. And they talk about different specifications that needs to be met to basically ensures that your pre-trained models are really good for your target task. And there is another set of work called as domain-specific model whale, which tries to think of models as like a software, like in software reuse, right? There are a lot of work has been done in the software community, which talks about how do you reuse a software, how do you specify software, etc. And this work kind of bridges or links to how you can think about machine learning models through the software lens. And next, I would like to hand over to Ahmed, who will talk about the challenges and the activities happening in our working group. Thanks.
Thank you, Sanjay. So, I mean, Sanjay built the base for what do we mean by reusability, but there are specific challenges that we need to think about. Okay, when we want to reuse a model, what are those challenges? I mean, you can think about, first of all, finding existing models. So finding a model that is already out there to start reusing it is still a problem. This is part of the challenges. Lack of an easy deployment environment. So if there's a model, you know, well, you need a Python environment or any other programming environment with specific packages and dependencies to be able to reproduce the same thing. So making sure that environment is reproducible and easy to deploy is another piece of that challenge. The model formats themselves have different kind of versioning and different standards. So having an interoperable format or making sure the models that are published are stored in an interoperable format is another part of that challenge. So if different users are using different packages and environments, they can easily read those models. The data preparation, so each model has its own specific format and kind of shape for data to be input to them. So making sure there is a reproducible and reusable pipeline for preparing the data, even if you know what data to use, let's say, I don't know, you're using MODIS satellite data for input, you need to know how specifically to input that model, that data into the model. So the right format and shape, reproducing that and reusing that is another piece of the challenge. And finally, measuring and quantifying the performance of a reused model. So how is the model performing on an existing training data set, and how to quantify that both in kind of machine readable terms. So there's a easy way to find models that have the best performance, and also in a descriptive and human readable sense, that someone with knowledge of the domain and the machine learning kind of technology can understand how the model is performing. So these are the ones that we have already come up in our working group discussions, and we're sure there's a growing list here. There's other challenges. These have been the top ones that we have come across, and this will be one of the questions in the breakout session. So you talk about the challenges you might have faced in reusing an existing model. Can we move to the next, Sanjay? So in this working group, which is the NASA ESDS, Air Science Data Systems Working Group, we have a working group called Machine Learning Capacity Development. And as part of that, Sanjay and I are leading this basically model reusability task. And the goal here is specifically to help earth science researchers and data scientists to better use existing models on remote sensing data. There's a growing number of papers and publications on remote sensing data in particular to use machine learning techniques. But there is a lack of, okay, how can we reproduce and reuse these results of those? So we want to really develop a guideline out of that. The output will be a best practice guideline for model reusability, both from a perspective of I'm a user, I want to reuse a model, or I'm a developer and a researcher, I'm publishing my model, what should I do to make it reusable? And we will demonstrate this using use cases. We have one I will present in the next slide. And in a specific, we are not talking about data pre-processing and harmonization of data, because these are kind of sometimes mixed together. And there's actually a session right after this session at the ECIP today on the data interoperability. That will be the place to talk about data and making them more interoperable for ML applications. But in our working group and in this session also, we are specifically talking about the model part of it. Next slide, please. So one of the use cases we are now kind of picking in this working group and working on that is an existing crop mapping using Sentinel-2, the multispectral satellite imagery that is developed by the NASA Harvest team. It's Kenya, and the model and the source code is public on GitHub. We have picked it as an example because it has the best resources we have seen so far. And we are kind of going through 3 questions and kind of developing the guideline. One is how to produce the results of the existing model. So using the same code, the same training data, the same input imagery, how can we reproduce that result? We are not reusing it. We are basically reproducing the same result. But then going through 2 reusing kind of use cases. One is inputting new imagery from a different region and running inference using that model. Can we do that? What are the considerations? What are the steps as a developer you should follow? And then trying to reuse the existing training pipeline and retrain the model on another training data set or another type of source imagery, which in this case, we are targeting HLS, the harmonized Landsat Sentinel product instead of Sentinel-2, and basically retraining the model from scratch. So these are the 3 kind of use cases we are running on that specific model. And we have already kind of went back, I would say 5-6 times to the developers asking questions. While they have a very good README and guideline in the GitHub, it is still not there in terms of fully reproducible and reusable that you can take it off the shelf and do that. So as part of that, we'll develop the guidelines that I mentioned to how to publish your model to ensure users can reproduce and reuse them. With that, I think we have another slide with the references, particularly the ones that Sanjay talked about. These are the papers that talk about reusability and reuse of machine learning models within the context of the AI ML community. So if you're interested, you can check them out. And just to say that the links for the presentations are also in the Google Doc, so you can check these resources from the Google Doc links. With that, and I know we're out of time, but we might have 1 minute for any questions or feedback. And if not, we can move to the next presentation, but feel free to raise your hand or type your question in the chat.
Hamid, you're muted. I think there's 2 questions, one from Jipeng and another from Douglas Rao.
Yeah, Jipeng, you can go first.
Hi, nice presentation. My question is in terms of helping other people to reuse the model, do you think it's useful to capture benchmarks cases with both training data and a model?
I can jump into that. I mean, it is key. You can reuse a model, or particularly reproduce a model without access to the training data. So that's a key piece of the puzzle, definitely, yes. And that's why we picked this example that I mentioned, because the training data for that is also available and publicly accessible.
Thank you.
Douglas?
I think you use the word reuse in a more like broad way. I know I now sounds like a annoying person trying to figure out what's your real definition of reuse, because it seems like you mix reuse, reproduce, and replicate to some extent in this presentation. Because when you say you have your model and you use the code to train the model using a new different training inputs data set, for example, the harmonized Landsat Sentinel data, that sometimes you should define that as a replicate instead of reuse of the model. So could you just clarify what's your definition of reuse in this case?
Maybe I can jump in. I think the definition for reuse, we are trying to you follow what has been published in the AI and machine learning community. It's mainly using existing pre-trained models. Sometimes you can use them in conjunction with, say, transfer learning or federated learning. But the traditional definition is you want to reuse existing pre-trained models. And as part of the working group, the slides which Hamid talked about, right? The application, the use case application for our working group. So there, because some of the members did not have the machine learning background, so we wanted to actually show the first part as well before we can actually reuse the model. So that's why Hamid talked about how are we getting the data and training the model first before we can show how to reuse the model for the current use case. Does that answer your question?
Yep, right, thanks.
Thank you.
Thanks, Sanjay. So in the interest of time, if you don't mind, let's move to the next presentation. And I think some of these questions would be also good to dive deeper into the breakout sessions. So please join the breakout sessions and we can have a more detailed discussion that time. But without further ado, so our next speaker is John Duckworth, who's talking about the geospatial machine learning model catalog. John?
Hey, thanks, Hamid. Yeah, so as Hamid said, my name is John Duckworth. I'm the technical lead and geospatial software engineer at Radiant Earth Foundation. And I'll be speaking a little bit about our efforts to catalog geospatial machine learning models. So I think Sanjay and Hamid covered this pretty well, but why are we going through this effort? Well, for starters, machine learning workflows, and particularly ones that deal with Earth observation data, are extremely complex and resource intensive. It typically involves some iteration on creating or finding training data, which is a combination of source imagery and your labeled data, at least in the case of supervised learning. Training your model, deploying that model in such a way that you can generate predictions or inferences, measuring the performance of that model in terms of accuracy and other factors, and then using that information to inform how you need to retrain that model or create new training data in order to improve performance. So each of these steps can be extremely complicated. It can require a lot of specific knowledge. It can be very expensive. And so there are some real benefits to making the results of each of these steps searchable and findable, both to you and to others. One of the benefits is obviously just the reusability of existing resources within your own organization. If you can easily reuse resources that you've already spent time creating, that's going to save you money and time and allow you to focus on other things. Sanjay and Hamid also touched on the idea of the reproducibility of model results and published results. So having a clearly cataloged ML workflow allows you to reproduce the data, the training, the model, the predictions that went into to generating those results. And then it also just enables the easier search and discovery of models and training data for any number of applications. So the ones that we've talked about today, but there may be other reasons out there why somebody would want to find and reuse either the data or models. One of those might be the increased adoption of published models into production systems. So once a model has been developed, there might be an organization out there that wants to use that to generate business insights. And so allowing them to really easily find and use that model is key for the adoption. So there are existing, there's existing work out there to cover various parts of this ML workflow. Many of you are probably familiar with the spatiotemporal asset catalog, the stack spec. That in our view, that's really a way of describing some of the source imagery and other source data that goes into some of these machine learning for Earth observation workflows. In addition to the core spec, which really provides a way of in detail describing that Earth observation data like satellite imagery or aerial imagery, there are also a couple of extensions built upon that spec that allow us to more specifically describe training data and how it's fed into the machine learning model training process. So one of those is the label extension. The label extension really provides a way of linking labels to source data that they can be applied to, and also provides a way of giving additional metadata about those labels. So things like what are the classes that are included if that's appropriate, what format are they in, things like that. The ML-AOI extension is a relatively new one that was developed by Xavier, and the goal there is to describe the train, test, validate split that was used to train a model. So that ML-AOI extension can point back to resources that are described by the label extension, but then it groups them together so that you can reproduce that training split that you need to make those models more reproducible. And then the one that I'll be talking more about now is what we've been developing at Radiant along with some of our other partners and collaborators, which is the geospatial machine learning model catalog. And this is really designed to be a specification to catalog both the machine learning models themselves, but also their performance metrics, and also any information about the environment that you would need to in order to deploy those to generate predictions. So what are some of the goals and the guiding principles in developing this? For one, we want it to enable searchable and cloud native APIs for model discovery. So that means we want it to be in a format that's easily incorporated into things like web APIs and easily used on cloud platforms. We want it to support the reproducibility of both the training environment, which includes the data, but also software dependencies, hardware that are required to train the model, but also the model results, predictions, and performance metrics. We also wanted it to include some form of recommendations and constraints on the model use. So beyond the conditions under which the model was trained, where do the publishers believe that this model would perform well or should not be used? We wanted it to build on existing standards so that we're not reinventing the wheel. And so we're using JSON and Stack as sort of the core for describing a lot of our training data. And then this one's in italics because it's still really a work in progress and we're looking for more feedback on this. But we wanted to provide a way to describe spatially and temporally resolved model performance. So what that means is, how does this model perform under certain conditions? How does it perform on Sentinel-2 data over North America versus Sentinel-2 data or HSL data over South Africa? And then we also want it to be community driven, and we'll provide some links at the end of this presentation on how you can get involved if this is something that you're interested in influencing the development of. So just looking at the specification itself, the entry point is sort of a top level JSON object that contains some kind of high level metadata about the model, including an ID, the type of model, information about licensing and contact information, citation information as well. And then it has more detailed sections that describe some of the components that are required to fully catalog the model. So things like the training environment, the input and output formats of the model, the runtime environment, so how you would actually go about deploying and running this model to generate predictions, and then those usage recommendations that we talked about a little bit earlier. I'm not going to go into too much detail on each of those different sections. I will provide a link to the spec, and so you're welcome to check that out in more detail later, and we can talk about it during the breakout sessions as well, I think. But just to give you a sense of what the model training section looks like, the idea here is to describe both the training environment and the training data sets. So the environment includes hardware and software requirements for training the model, or rather maybe hardware and software that was used for training the model so that you can reproduce the training environment. And then for the training data sets themselves, we really utilize links to stack collections that implement some of those ML specific extensions like the label extension and MLAY extension. For model runtimes, the goal here is really to describe the conditions that you would need in order to run the model to generate predictions. To sort of limit the scope of this, because this can be a really big problem, we decided to initially stick to support for Docker containers and Onyx files. Onyx files being sort of the serialization format, Docker containers being a containerized format for running the model. The idea here would be that people could provide a link to that container or file somewhere, and then also a description of the environment that you would need in order to run it. We also include a section for code and usage examples so that people can provide sort of tutorial-like assistance there too. So in terms of what's next for this, we're still early in the development of the specification, and as I said, we want it to be community-driven, so we're really looking for input on this. We have a need to develop out the section on model performance metrics, how we define those and how we capture those, and we'll have a question about that in the breakout sessions. We also are interested in feedback specifically on the runtime descriptions. Are we capturing enough information to reasonably run these models to generate those predictions? And then there's also needed on some of the work needed on some of the stack extensions that I mentioned earlier to make sure that we're covering all of the use cases that need to be covered here. And then in that vein, we're going to be announcing in the near future a virtual sprint event that'll happen probably in early September. The idea being to bring together some people who are interested in this topic to test out implementations of this spec and give us feedback to drive future development. And so here are some resources that can be used to get involved with this. These specs are all hosted on GitHub, and so you're welcome to go check out those in more detail, join the conversation through issues and pull requests there. And again, we'll be announcing our virtual sprint event in the near future, and that's another way to get involved as well.
Thank you, Jeff. We have a few minutes for any questions. I see one in the chat from Duckworth. He's asking about the model ID. Who is going to issue that? Because the description says the provider. So who is basically the provider in this case? An agency, institution, a researcher, and also who is the target user of the catalog? So two questions there.
Yeah, good question. So the issuer of the ID, I think that still remains to be seen. It's a discussion that we've been having with some of the partners who've been involved in this so far. I don't think at least not that we know of, there's not a great central source for that right now. And so maybe that would emerge. Right now, we were thinking that at the very least, that model ID should be unique within whatever the service is that's providing these catalogs. So for instance, if we're implementing this in our Radiant ML Hub API, we would make it unique there and probably make a best effort to make it unique among all the other services that we're aware of too. But hopefully a better solution to that will emerge. In terms of potential users, I think we're kind of targeting two broad audiences. One would be the research community and enabling, as Hamid and Sanjay have mentioned, the reproducibility of model results and published results. The other audience is, I think, what we would describe as ML practitioners. So people and organizations with some level of machine learning expertise who want to, maybe for lack of a better word, shop around for models that meet their needs for analytics and then deploy those models in production. Maybe also with some element of retraining them or building new models on top of them. So that audience is really more geared towards people who are looking to gain sort of business insights by using these models and need to find out where they work well, how they were trained, what the architecture is, things like that.
Thank you, John. Maybe one more question I see in the chat, and then we should move to the breakout. So Fotis is asking if beyond the infrastructure specification, there's a particular standard or schema used for describing the model.
Good question. So you're thinking in terms of say like describing the model architecture, weights, things like that. Yeah. We haven't gotten into the specifics of that yet in the spec. I think there are two reasons. One is if that can be captured through things like the serialization or containerization format, or if it can be captured by linking to the model code itself, then that might be a more flexible approach rather than us determining what those fields should be. However, having said that, there's no reason why we couldn't add those fields in. You know, as I said, we're still early in the development stage here, and so I think we're looking for input on what information do we need to surface in that sort of top level metadata document to make this usable. The other reason why we haven't necessarily focused on that early is our focus has really been on searchable models. And so we've been trying to sort of focus on the question of if somebody was trying to determine whether they could use this model for a certain purpose, what's the key information they would need. There might be elements of the model architecture that would need to be included to answer that question. I think we probably just haven't quite gotten there yet, but it's a good question. It's probably a need for future development there.
Thank you, John. So in the interest of time, and because we want to have a good breakout discussion, let's move to the breakout session. So you will be assigned automatically to basically a breakout room. Annie, you will handle that?
You bet. So right now I've got 5 set up, and we've got
44 people.
44 people. So I think that's
We're actually losing. We lost 2 people. 42,
I know that's,
so.
that's the curse of the breakout, but I encourage everyone, even if you want to silently listen in your breakout room, you're welcome. This does not mean forced participation in any way. So just
let's go with 5 then. Yeah.
Yep, happy to have flies on the wall. That's always, listening is always a great thing to have as well. So I'm going to create 5 rooms, and people are going to automatically be put in a room. So we're just going to have kind of a mix of folks everywhere. Does 5 work for you, Hamid?
I think 5 is good. Yeah, given our number, 5 is good. Yeah, just the moderators, make sure you are in a different group, basically. I put numbers in the notes down in the Google Doc, as you see. I think 1 is Sanjay, 2 is me, 3 is Fotis, 4 is John, 5 is Kevin.
Okay, I will just move those. I'll move people to those rooms, and as soon as they're created. Yep.
Yeah, and these are the questions I have on the screen, but you will see in the Google Doc too. And feel free to start from either of them that the group feels more comfortable. You don't need to start from 1 and go to 5.
Yeah.
If you feel you want to jump on 4, go ahead and do that. But just make sure both the moderators and the participants participate in note-taking. The key piece is to capture those discussions and then report out at the end. We appreciate those feedbacks. Anything else, Annie?
I think that's it. So I'm going to create the rooms, and then I'll move the moderators to the appropriate spaces. And again, feel free to be an active listener in any of the rooms with no need to jump in or be called out if you are put in a breakout. So I will open the rooms now. And
and we will be back at.
Ahmed?
I think because we need breakout, we need to report out. Let's be back at 12:20 Eastern time, so half an hour.
Okay, great, perfect. Okay. All right, we've got everyone back. Hamed, do you want to start the report outs?
Yes, thank you, Annie. Hopefully everybody had a good breakout discussion. I will go over basically groups by order, and then we can have each group. If you can summarize in 2 minutes, that would be ideal, and then we can wrap this on time. Sanjay, do you want to get us started?
Sure. I think we had around 7 participants, which was really good, and we had a brief round of introduction from everyone, just to know where they're coming from, so that we can have like meaningful conversations. I think we had a nice conversation about all the 3 topics actually, all the topics covered in the talk. So first we talked about what does fair concept mean with respect to machine learning models, which is the focus of the first talk, right? And what's really happening in this community. Why do we need fairness or fair? Why do we need to talk about fair concept with respect to machine learning models? Many people are familiar with the fairness with respect to data, which Fortis also emphasized, right? But the goal is what does it mean to be fair with respect to the machine learning models? We had like good conversations on that, and then I think some participants actually shared their experience on why this is important. So for example, we need to have this findable, accessible, interoperable, reproducible models, or we need tools to find these fair models, because for beginners, right, they're really interested in to get into the field, and it makes sense which model you actually find them, or can they search and find the right models for their application. That's really important. And the use case was like how students use the find models for building their projects or using in their projects. There was discussion about having a community for this fair ML. And I mentioned Fortis that I have started this community last year, and looking for more people to contribute. And then we also discussed how people think about model reuse from their perspective. What are the good practices they follow? So, for example, one of the things people do as a group is to, when they participate in a group, right, they read the documentation, and if they're unable to identify or understand the code, they will reach out to the original repo authors or the people who are in charge of maintaining the repo, and figure out and try to understand these things, like why the code or the model was created, how they created it, and not see ML actually as a hammer for all the problems which you can solve. So don't consider problems as nails and ML as a tool to solve the problems, but really understand why the model was actually built, so that you can figure out whether you want to reuse the model or use the model for your own application. We also had questions about the model specification. So this was actually a follow-up question from the talk which John presented. So there was a question about how do you ensure version control in the specifications? Do you have DOIs for the codes if you have different versions? How do you manage that? How do you, when you publish the model, right? How can you cite those models in publications and in other places? So that was a discussion we had. And finally, we also had a discussion about the tools and specifications. That is, what does fair and reuse models need to have, so that it not only covers just about the license or the specifications or just the governance of the model, but what does it really mean to have, what tools should be there to actually capture the full concept of the fairness and the reusability and the reproducibility for the machine learning models. So these are the things we discussed. We tried to touch upon all the questions. I think the time was limited, but we had like good discussions. Thank you.
Awesome. Thank you, Sanjay. So I will report on group 2. I mean, we started talking about actually a relatively new, but from previous ESIP meetings, practice about a working group on dynamic data, basically, and kind of practices about how to do metadata capturing of models, not necessarily machine learning models, but generally other models, particularly in the health domain. And a good kind of discussion from one of our participants about the resources and metadata that is discussed in that working group and is already out there. We have the link of that in the notes. So what are the basic outcomes of that? And there was very much overlap between those and the kind of the catalog metadata that John was presenting. So that was a good discussion. And we had some follow-ups about the performance metric. The conclusion was, I mean, there wasn't any conclusion. It was more of a consensus that there should be a way for the developer to report on that and say, okay, this is my metric and this is the value, rather than predefining those. And letting gradually the communities to decide what is the kind of the common metric that everybody should report for their application that is specific. We talked about fairness in ML, and there was a good point that we should think about who is the user of the fairness when we are talking. Are we talking about internal researchers within an organization or unit, or are we talking about general public? And this is a spectrum. So when we define fairness, we define reusability, interoperability, we should keep in mind who is the end user of that catalog or metadata or product. So that's a key piece to keep in mind. Provenance, capturing the provenance of how the model is developed from the data to the end of that in a metadata sense is critical. So what metadata should be basically included, particularly thinking about the training fragment. The provenance is a key piece. We had good kind of, I think, feedback on why not using containerization and Docker in particular. But there's two, I think, feedback there. One is, okay, the container should be also not just the container itself, but the code to generate and build the container itself. So if someone wants to make a slight change, they can go back and basically reproduce that. And at the same time, it should be the container itself. So if someone wants to exactly reproduce the same result, they can literally do that without the need of changing anything. So the two ends of, again, that thing should be included. And I think that was mostly it. And in the interest of time, I'm gonna pass it to Fotis.
Right. Yeah. Thanks. In group 3, we had an overall interest discussion. We tried to go through all 5 questions. We initially started to capture a bit about fairness, and in particular, what would fairness in machine learning would capture, like models, processes, or platforms. There were some interesting points that if we want to see, like from a scholarly communication point of view, what is critical is to actually capture first what are the practices of the overall community when applying and when using machine learning. This would also help understanding how fairness would be facilitated in this context. It might also be quite interesting to try to identify what are the real differences between the fairness for machine learning and looking at fairness for software and data. This might not necessarily be the same as redefining the FAIR principles for machine learning from the get-go, but essentially really tweaking the two different sets for software and data to better fit machine learning. We had a brief discussion about tools and specifications for model reusability. In that context, we reviewed, we had a very brief discussion about what are the existing recommendations and what would be the appropriate way to identify the steps to reuse a model. So if you have a model, how can you reuse it in practice or not? And this also led to the final point, the final question there about the metadata that will be captured for the requirements for reproducing the model versus requirements for reusing the model. And this also led to a few questions about what are the disciplinary differences that might exist. Because in one case, it might be a completely set of requirements, for example, life sciences, as opposed to geospatial sciences, given the underlying differences in the domain. I think that's sort of the quick overview of the discussion. I've tried to capture this as much as we can with the full document. And I'll pass on now to, yeah.
John, do you want to go next?
Sure. Yeah, I'll keep this short. So sorry if I miss anything that we discussed, but a big theme in our group was trying to capture the entire ML workflow in order to create some reusability and reproducibility, not just the model, not just the data, but really the entire workflow of training and generating all of those products. And so in that sense, we should really be applying FAIR to that entire workflow rather than just the end product or the model. We also discussed the importance of capturing the provenance and the processing of the data as part of that training catalog. And we were kind of discussing whether there are good examples and tools for models being cataloged well that are already out there. There was an example of a tool called GeoWeaver that's under development now that we have the link to here that helps people sort of automate the generation of their metadata. And so we thought that was an important step, and probably the path forward is to have sort of an interplay between developing those tools and having them inform best practices, and also having the best practices inform the development of those tools. I think there probably needs to be a bit of back and forth there. In terms of the model cataloging spec, we discussed a little bit about the possibility of using DOI as the unique model ID, but sort of agreed that there are enough cases where models might need to be published or metadata might need to be published without a DOI that didn't make sense, but that we should definitely capture that information, and we do within the model metadata. Let's see. In terms of the model performance metrics, there was sort of a recognition that self-reporting can be either consciously or unconsciously biased around those metrics. And so it's really important to tie those to benchmark data sets so that they can be truly reproducible and objective. We're sort of talking about the users of the metrics, which are both researchers and potential users of the model who want to know how well it performs. And then we also thought it would probably be useful for there to be a mechanism of some kind for people besides the model publishers to report back on if they've run the model and generated performance metrics, for them to be able to report back on what those metrics were, so that there's sort of a feedback mechanism on how this model performs under different conditions.
Thank you, John. Kevin?
Yeah, so I'll definitely keep it short too. So we didn't really have anyone in our group that like directly is working with models. So we kind of took like a more free form approach with our questions. And one of the kind of things that we discussed was just, so Docker containers won't always work for everyone, just because like if you're in either a Windows environment or like you're at an organization where your access on your computer is limited to not admin access, you can't really use a Docker container. And so that was one of the issues that might be raised whenever we're talking about like, how do we make these models more reusable and have like a reproducible environment. Another thing we talked about was just how much metadata should be included in those catalogs. And so kind of what we landed on is anything that's useful for like a machine readable kind of searching capability should be included in those catalogs. But then anything outside of that that's more human readable, like documentation, should be linked out somewhere else. Kind of this like the same approach we kind of take to, with Stack. And then let's see, another thing was just so scientists typically, they're smart people, but they're not computer scientists. And so really having like good documentation on how to set up an environment, how to reproduce that model, and just more like kind of training tools are typically needed for that. Let's see, and we have a couple more questions or discussion topics that we added to the notes. But yeah, for time purposes, I'll end it there.
Awesome. Thank you, everyone. This is very good discussions and good feedback and points that every group has raised, and I appreciate all the engagements from everyone. I think we have a good summary already from those discussions. I don't want to do another round of that in the interest of time. But I want to first of all thank you, everyone. Thank you, ESIP and the team who kind of has been running the conference the whole week. Thank you, and doing that remotely, I can imagine there is an extra level of effort. Thank you to our speakers and also all of you who engaged and stayed longer than the session time. We appreciate that. We will, Sanjay and I will kind of synthesize this and derive those 3 takeaways from our session and put it in the master Google Doc from the conference that you will see. But other than that, please be engaged. There's also the Slack channels for the ESIP, which is in the Google Doc, and also the ML Hub Slack channel, which we're talking specifically about the metadata catalog. Feel free to join those. Link to the presentations is there. And yeah, please be engaged and be in touch. Thank you, everyone.